Very good morning, all of you. Welcome back to third unit, second topic, spatial and non-spatial data for fourth year, first semester BTech Civil Engineering students. Today we are going to discuss about spatial and non-spatial data. First, introduction. The most important expensive component of GIS is data, which is generally known as fuel for GIS. So, one of the most important component in GIS is data. It is gathered from satellite or it is gathered from field. But data is the most important to run GIS. It is just fuel of GIS. So GIS data is combination of geographic and tabular data. We have two datas. One is geographic data, second one is tabular data. You already know geographic data. Geographic data means earth surface features. Is it field data or satellite data? What about tabular data? Tabular data is nothing but a attribute data. Geographic data and tabular data. These two data we will discuss it today briefly. Perhaps the most important component of GIS in the part of data used in GIS. Here, first geographic data. For example, this is geographic data. In this geographic data, you can find out two major parameters, features on the earth surface. One is hilly area, second one is forest area, third one is agriculture area. These three indicates the geographic data. Is it collected by satellite or field data? Field. Anything, this is geographic features, earth surface features collected by the sensor. This is called geographic data. What about tabular data? For example, here how much area covered agriculture area on the earth surface, how much forest is covered on the earth surface feature, how much area covered the hilly area. That area, length, width, breadth, elevation, these values, it gives the values of the particular geographic feature. That is called tabular data. Tabular data is nothing but a attribute. It is also called attribute data related to geographic features. So, just if you observe this right side figure, this is one is grassland, hilly area and forest area. Like that we can classify these three. First one agriculture area and hilly area, forest area. Like that we can classify this. So this figure, after classified this, it appears like this. This is one is polygon, this is the line and point. We will discuss later that polygon, line, point. Now simply this image we can graphically represent it like this. Then this indicates, this black line indicates the attribute data belongs to this agriculture area. See, polygon attribute table. Attribute table indicates what? This agriculture area, how much area covered the agriculture area, agriculture land, agriculture length, width, breadth, elevation. Like that different values represent the attribute data, tabular data. So that's why this is a spatial relation tables. This is the spatial information. Means this is the spatial agriculture area, hilly area, forest area, This is spatial representation, spatial information. This spatial information related to gives the tables. This is the attribute table. Okay. Today in this slide you learned two types of data. One is geographic feature data, second one tabular data. Geographic feature data also called spatial data. It indicates the latitudes and longitude. This is the spatial data. The spatial agriculture, forest, hill area. This is geographical features indicates the spatial data. The spatial data. The spatial data relation to the relational to tables. It gives the attributed in relational tables. Okay. So I hope you understand. Whenever you see any satellite image, you have two data. One is geographical data, second one is tabular data. Geographic data also called spatial data. Tabular data is also called attribute data. Now, GS data types. There are two types of data are used in geographic information system platform. That is, one is spatial data and non-spatial data. We have two types of data in GIS. One is spatial data, another one is non-spatial data. You know, spatial data is nothing but a earth surface feature, geographical features. Non-spatial data related to tabular data. Now, spatial data are those that have coordinates, latitudinal and longitudinal, that shows position of the feature. So spatial data shows the position of the feature. Just now I told now position of the feature. See, this is the agriculture land, spatial data, forest land, spatial data, hill area, spatial data. So it gives the latitude, longitude, which position on the earth surface, exact location. It gives the spatial data. Spatial data always gives the location of the feature on the earth surface. It represents the location of geographical entities as well as the spatial domains that are represented with the help of point, line, polygon. How to represent the spatial domain? Point, line, polygon. I will explain point, line, polygon next slide. Now the spatial data further divided into two types. One is raster data, second one is vector data. Spatial data is nothing but a geographical features. That geographical features means spatial data, it also gives the location of the feature on the earth surface. Further, this data is divided into two types, raster and vector. What is raster data? Raster consists of matrix of cells organized into rows and columns or grid, where each cell contains a value representing information. Raster data is nothing but a one type of spatial data. So how to representation of the spatial data, how to visible the spatial data, raster data, how to visible the raster data on the image? Just matrix of cells. Raster data consists of matrix of cells. See, organized into rows and columns. If you observe here, this black and white pixels matrix, row and column. Is row and column. This is the Landsat image, this satellite image, which are represented in cells, where each cell contains the value representing information of the satellite. Each cell gives the information about the earth surface feature. Each pixel represents the earth surface feature. Example of raster data: satellite imagery, aerial photographs, scanned maps. Okay. The raster data are the data that have individual pixels. Each pixel has its spatial location in referenced on Earth surface. So, I'll explain. Each pixel raster data consists of composed of all pixels. Each pixel gives the spatial location of the Earth surface. Next point. When the data is georeferenced, the data give and every pixel its location information. If the data georeferenced, I already explained the georeferenced data and non-georeferenced data. Georeferenced data, it gives the exact location of the Earth surface on the image, latitudes and longitude. So that's why whatever you get data from the satellite, first you have to do georeferencing. In practical, you can do one of the experiment georeferencing. One is exercise is there. Thus the attributes is represented as a single value of each pixel or cell, that is called digital number. So the attribute is representing a single value of each pixel, cell is digital number. Each pixel gives the brightness value, or it is also called as digital number. Simple. Raster, if you see any raster image, it appears grid size, pixel size. That pixel size also gives the resolution of that image. Pixel size is equal to resolution of that image. So here raster, if you see any image, the raster, each pixel represents the spatial location on the Earth surface. That is, you remember. All pixels in raster data must be the same size, determining the resolution. A pixel or cell represents a square kilometer, square meter, or even a square centimeter. Pixel or cell are arranged in rows and columns that construct a certain matrix format. This is a column and row. It constructs a certain matrix format. What is the advantage of raster data? It is very simple data structure, compatible with remotely sensed imagery, continuous feature as best representing using raster. Overlay analysis is very easy to perform with raster models. Next, what is vector data? A representation of the world using point, line, polygons. Vector models are useful for storing data that has discrete boundaries such as country borders, land parcels and streets. In the vector data, the spatial information are recorded as XY coordinate. Till now, we discussed about the raster data. Raster data just appears in the grid size, pixel size. Each pixel represents the DN value. Now, vector data. Vector data represents the X and Y coordinates. X and Y coordinates in two-dimensional. So, vector data always representation point, line, polygon. It is useful for storing the data discrete boundaries such as countries and parcels and streets and forest and road network, river network, and different types of forest applications. Anything. If you see any vector data, you can classify it into three types. One is polygon. You can easily digitize the data, point, line and polygon, and stored the data in vector form. See, this is the topo sheet. Here if you want to digitize this topo sheet, what should you do? Just you have to consider three tools. One is polygon, second one is line, and point. Why? Because if you observe this is the road. So road is nothing but a line. That's why you can take the line tool from the software, then you can digitize this road network like this. For example, this blue dots indicates some post office, some temples, church, huts. So this type of huts, buildings, huts or bus stops, small church temples, it indicates point future. Then you can take the point tool from the software, then you can assign the points on the topo sheet. Third one, if you observe here, this is the water body, this is the river water body, this is also one village. So some area is forest area. If you observe some areas like this, then you can take the polygon. You can digitize it as a polygon on the topo sheet. So this is stored in a vector form. After completion of this, you can store this topo sheet as a vector data. That is vector data. Okay. Whenever you get satellite image or topo sheet, just you first find out which features are present in the topo sheet. Based on the features, you can choose polygon, line or point. For example, in the topo sheet, if you find out the road network, then you can take the line tool, then you can do digitization line. If you find out any small huts, temples, post office, bus stop, like that, then you can take the tool from the point tool from the software, then you can assign the points on the image. Then if you find any areas means agriculture area, forest area, water bodies, like that, then you can take polygon tool from the software, then you can digitize it as a polygon on the topo sheet. After completion of point, line, polygon, then you can store this thematic map in a vector data, as a vector data. Okay. Then one by one we will discuss it. See, the point features are recorded as a single x and y pair of coordinates. Vector data are the form of point, line, polygon that are recorded in a spatial information x and y coordinates. There are three ways of representation. First one, point feature. It has 0 dimension. See, if you find any small huts, temples, post boxes, post offices and bus stops, like that, you can assign the points on the satellite image or topo sheet, then you will save as a vector form. This is point features. This point features have 0 dimension, represented by xy coordinate, and size also 0. The area size is 0. Here no area, small area, 0. So mostly used for denotes a single particular feature, town, power pole, like that, extra. So single features you can represent in a point feature on the topo sheet or satellite image. Line feature. It has 1 dimension. You can represent the line length. distances, lengths, you can take 2 points and draw the line from one point to another point. This is the line representation, represented by connecting two or more pairs x and y coordinates. It has its length value, commonly used to determine digitized roads, rivers, stream, and so on. So line features all comes to this category. Connected the dots and become line feature. This is the vector type data. Third one, polygon feature. It has 2 dimension, can represent the length as well as the width. He have some length and width also. It is represented by connecting 4 or more pairs xy coordinates. The starting point should be in the ending point. This is an area. It is commonly used to digitize the future, have closed boundary, national parks, agriculture fields, forest area, water body, like that. If anything, just you can close this boundary, it gives the polygon. Polygon always gives the area. Linear feature always gives the distance or line features. Point features always give the single feature. This is the point line polygon. What about non-spatial data? So first you have to understand what is this image. If you observe this image, so much of area is, this area is agriculture area, and this area river. Beside the river all are agriculture. This area is the forest area. This dark green represents the forest area. This is the road network. This is the road. This settlements indicates village. So you have to find out in this image forest, agriculture, agriculture lands, river, road network, and village. Now spatial data. Spatial data is nothing but a location, geographical features located on that surface. So these are all spatial data. What is the river, road network, village, and forest, agriculture? These are all spatial data. Now what is the non-spatial data? For example, in this, if this is the village, in this village, how many buildings are there, how many road network, how much of area is covered, how much length, how much width, how many water tanks inside the building in the village. So these are all non-spatial data. For example, in MVR, for example, our MVR, if you observe our MVR college is the entire building. How much area is covered on the earth surface? The entire building. How many classrooms enter the building? So MVR college is nothing but a spatial data. Inside the MVR college, the number of classrooms, number of departments, number of students, number of faculty, these are all attribute data. So spatial data represents the entire area. Non-spatial data represents the inside that area, how much of area, how much length, how much width, how many students, how many classrooms, how many departments. It gives the depth of that area. So non-spatial data gives the entire information of that area. See here, non-spatial data. The data that describes the characteristics of geographical features. Geographical feature is nothing but MVR ecology. What are the characteristics of the MVR ecology? What are the characteristics of the forest? What are the characteristics of agriculture? What are the characteristics of river network? So it gives the non-spatial data. Non-spatial data, also called attribute data, are characteristics of the data. Non-spatial data are represented in tabular format. For example, administrative boundary table has population information. In the administrative boundary, what is the population information and district name. So like that, source of non-spatial data. GS data from libraries, national and international mapping agencies, elevation data, bathymetry data, georeferenced image, time series multispectral satellite image, town planning, management department, state, national agencies, and detailed district or municipal data. It gives the detailed information of the any area. That is called non-spatial data. These are all examples of non-spatial data. These are source of non-spatial data. Example, see, this is the total boundary of the one district. So this is total polygon. See, this is the shapefile polygon. Each state name, area, population. So like that you will give the different polygon. If you click here, then it display like this. 1, 2, 3. These 3 I selected. 1, 2, 3. These 1, 2, 8. These rows, 1 row, second row, 8th row. So these 3 rows automatically selected in attribute table. This attribute table gives the information of the spatial data. This is the non-spatial data. This is the spatial data. Spatial data indicates the Earth surface feature. That Earth surface feature information we will get in attribute table. This is the difference of spatial and non-spatial data. It is software, GIS software. So difference between spatial and non-spatial data. Spatial data describes the absolute relation between the geographic feature, describe the characteristics of geographic feature. All types of data, objects, elements that are present in geographical space or origin, characteristics of geographical feature that are quantitative and qualitative in nature. Satellite images and scanned maps help to obtain spatial data. Town planning and management departments, libraries, national and international mapping agencies help to obtain the non-spatial data. Okay, this is the difference between spatial and non-spatial. Now you have clear idea about spatial, what is spatial data, what is non-spatial data. Now application of GIS. Applications of GIS. Applications used of GIS. First one, agriculture. GIS in agriculture helps farmers to achieve increase the productivity and reduce the cost. If you increase the productivity, reduce the cost, then you can use the GIS technology. It's very helpful for manage the farmers. For example, farm management, disease tracking, crop monitoring, yield prediction, soil moisture. So if you use GIS and GPS technologies to agriculture, it easily manage of land cover features, land resources by using geospatial technology. Then natural resource management for forestry, ecology, mining, petroleum, water resources. For forestry also we are using GPS and GIS technologies. So different types of forests, thick forest and thin forest, and decidual forest and So like that, different type of forest also in GS and GPS technologies, and ecology and mining. Mining also GS used for monitoring for soil, vegetation, surface, how the surface is groundwater surfaces, like that. We can also find out the mining also, petroleum water resources. By using this technologies, geospatial technologies, we can easily find out the this petroleum and water related works. Groundwater pollution zones also we can easily find out from using groundwater resources. And planning and economic development. So land use zoning, it is also used for emergency preparedness, population forest forecast, market analysis, transportation. Nowadays transportation is very important to use the geospatial technologies. For example, land use zoning. Generally, GS commonly used in urban planning or rural development. For example, emergency preparedness. So hazard mapping. By using geospatial technology, we using floodplains or hazard mapping, or you should identify the potential zones, and these are all emergency preparedness. So an emergency after flood, how much environmental impact assessments also we can easily find out by using geospatial technology. And population forecast also, how much area population increases or decreases, we can easily assess by using this technology. And transportation planning also. And geographical phenomena, events, climate change, we can easily find out the change detection of the climate. And urban growth, urban development also, sustainable agriculture, and water quality and availability, natural hazards and seismic. We should also drawing the mapping of earthquakes or volcanics, tsunamis, landslides, or weather events. And these are all we can easily find out the how much area affected of the earth surface. Then environment and land cover and land use analysis, modeling watersheds, soil erosion, for forest management, conservation and protected areas, vehicle routing, land use planning and management. So these are all applications of GS. Okay, thanks.